Alright, Chapter 9, Rational Equations and Functions. What this chapter is about: writing and using inverse variation, joint variation models, graphing rational functions, identifying asymptoms, simplifying rational expressions, solving rational equations. Keywords: inverse variation, constant variation, joint variation, rational function, hyperbola, branch, rational expression, simplified form, complex fraction, least common denominator, regional equation, cross multiplying. Alright, 9.1, inverse joint variation. You've use inverse variation, joint variation method. You learn that two variables x and y show direct variation of y is equal to kx and when k is not equal to 0. Another type of variation, inverse variation. Two variables x and y show inverse variation if y is equal to x over y is equal to k over x. If k is not equal to 0, the inverse equation, non-zero constant x. Non-zero constant k is a constant variation of the variable y is to vary inversely with x. Rewriting an inverse variation. The equation of inverse variations also are written as xy is equal to k. So set a data pair of x and y show inverse variation of the product x and y constant or approximate constant. Two types of variation, two types of variation. You have joint variation occurs if quantity varies directly as a product of two or more other quantities. For example, if z is equal to k xy, where k is not equal to 0, then z varies jointly with x and y. Other types of variations are also possible. Type of variation: each equation x is a constant and x is not equal to 0. Relationship y varies directly with x when y is equal to the equation y is equal to k times x. Y varies inversely with x when y is equal to k over x. Z varies directly jointly with x and y when z is equal to k times x times y. Y varies inversely with the square of x square of x. Y is equal to k over x squared inversely of the square of x. Z varies directly with y with x. So z is equal to k times y over x. 9.2, graphing rational functions. A rational function is a form of fx form and px and px over pq are polynomials, and qx is not equal to 0. Consider the parent functions of these graphs below. Each graph is a hyperbola following properties. X-axis horizontally asymptotic with y-axis vertical asymptom. So x is horizontal asymptom, vertical is asymptom. Domain range all non-zero real numbers. Graph has two symmetrical parts called branches. For each x and y on one branch, y is equal to 1 over x, and the corresponding point negative x and negative y is on the other branch. The function of form y is equal to a over x. Values a tells the shape of the graph. A is greater than 0. The hyperbola is first and third quadrants. If a is less than 0, the branches are second and fourth quadrants, hyperbola. As the absolute value a increases, the branches of hyperbola move farther from the axes. Graphing a rational function in form of y equals a over x minus h plus k. A graph of rational function form y is equal to a over x minus h plus k. Hyperbola, vertical symptoms x is equal to h, and horizontal symptoms y is equal to k. To graph rational function, you use these following symptoms. Draw symptoms x equal to h and y equal to k. Plot points on each side of vertical symptoms x equal to h. Draw two branches of hyperbola, approaches the asymptom passes the plotted lines. Graph a general rational function. Let px and qx be polynomials with no common factors other than plus or minus 1. Graph rational function f is equal to px over qx has the following characteristics. The x-intercept of the graph of the function fx are the real zeros of px, and the graph of fx, function fx are the vertical asymptotes of each real zero of qx. A graph of fx equals, example graph of fx equal to x3 over x squared minus 3x plus 2 has an x-intercept of 3 with the vertical asymptotes x2 and x1. Continuing on. 9.3, simplifying multiple rational expressions. In example of exercise 35, we will write the function answer the question fraction, numerator, denominator, non-zero polynomial, rational expression simplified form where numerator, denominator have no common factors other than plus or minus 1. Simplifying rational expressions, let a, b, and c be non-zero real numbers variable expression. C over BC equals A times C over B times C equal to A equal over B, divide out common factors. Okay, you can simplify rational expressions by factoring numerator and the denominator, dividing out the common factors as shown in example 1. When you simplify the rational expression, you can divide out only factors not in terms part. B, for example, you can divide out x because it's not a factor of 5. Multiple rational expressions. Because variables in rational expressions represent real numbers, the rules of multiplying rational expressions are the same as the rules of multiplying fractions. Multiplying rational expressions, so we have let a, b, and c be the non-zero variable expressions. Multiply numerator, denominator. A over b times c over d equals ac over bd. So we'd have okay. 9.4, dividing rational expressions. Dividing rational expressions, simplifying complex fractions. You also need to know how to multiply rational expressions. And in this learning, you will learn how to divide rational expressions. Let a, b, c, and d non-zero variable expressions using find quote in a over b divided by c over d. Rewrite the division as a property. A over b divided by c over d is equal to a over b times d over c. Multiply the numerator, denominator, factor of the numerator, denominator, if possible. Divide out common factors, simplify. Complex fractions. Fraction. If it is a fraction, it has a fraction and a numerator, denominator, or both. Simplify the complex fraction. You can rewrite the fraction and division expression. Follow the steps of the dividing fraction. A over b over c over d is equal to a over b divided by c over d equal to a over b times d over c. Number 4, exercises. 9.5, adding and subtracting rational expressions. You can add and subtract rational expressions the same way as fractions. So two rational expressions like the denominator would have a like denominator, add or subtract the numerator, then write the results over the denominator. In sample A, we have 3 over 2x plus 5 over 2x. So that really writes down to 8 over 2x or 4 over x. So, least common denominator. To add or subtract rational expressions, you have to have, with unlike denominators, first rewrite each expression. Have like denominators, use the least common multiple, original to common denominators. Denominators, add like denominator at the least common denominator. Nine six, solving rational equations. A rational equation is an equation that contains rational expressions with the side of the equation is a single rational expression you can cross multiply to solve. If a over b is equal to c over d, then a d is equal to bc. multiplying least common denominator. Another method of solving the rational question is to multiply each term on the side of the equation least common denominator of the term. The method works on rational expressions. Chapter 9 Summary Review, Inverse Variation, Constant Variation, Joint Variation, Rational Variation, Hyperbola, Branch, Rational Expression, Simplified Form, Complex Fraction, Least Common Denominator, Rational Form, Equation, Cross Multiplying. 9.1 was Inverse Joint Variation. 9.2 was Graphing Rational Functions. 9.3 Simplifying Multiple Rational Expressions. 9.4 Dividing Rational Expressions. 9.5 Adding, subtracting rational expressions, and solving rational expressions. 9.6 Chapter 10 Data Analysis and Probability.